Okay, starting. Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and be welcome to another episode of In Process Interview. It's very nice to have you here with me. It's a long time that I don't have any guests to talk to me here in my YouTube channel, but today I have a dear friend from Angola, and his name is Kelson Gando. And before he will talk about losses in atmospheric event. He will share a little bit of his experience that he writes in an article in a magazine, an engineering magazine. But before talking about that, we'll find a little bit about his study, his background, and also his experience in India. It was very interesting to me to know that, because I have a lot of followers from India, and you may find some interesting stories behind that. So, Kelson, thanks for accepting my invitation. Here in Brazil, it's afternoon, but in Angola, I know that it's evening. In Saturday evening is not everyone that wants to share his experience in the internet with other people. So please talk a little bit about yourself, and I have some questions to share with you. Okay, my friend?
Jefferson, thank you very much for the introduction, and it is definitely a pleasure to be here with you today. And yes, we always have time for friends, so I'm here. I will be more than happy to share my experience with you. And as you say, I did spend time in India. That was an amazing experience, but I believe you have a lot of questions to ask, and I'm ready to answer all those questions. So I'm open. I'm open. So for those of you who do know me, who do not know me, Jefferson, can you hear me?
Yes, for sure.
Yes, for those of you who do not know me, my name is Kelson Gando, and I'm a chemical engineer from the Georgia Institute of Technology. The institution is located in the United States. Okay, it is also known as Georgia Tech. And after my studies in the United States, I was able to go to India, where I obtained postgraduate diplomas in process engineering and process piping design as per ASME B31.3. Well, that is basically what I have to say right now, but I think you will learn more about me as we move along with this presentation.
Okay, guys. Just to something interesting. Here in Brazil, we talk in Portuguese. It's my mother tongue is Portuguese. In Angola, it's the same. It's Portuguese in Angola. Angola Portuguese is closer to Portugal. Here in Brazil, we have our own kind of Portuguese. But to share the experience and to let more people knowing and be beneficial of our experience, we are doing this live session in English. So it's interesting to talk about that, because I have some meetings with Kelson, and we already did this kind of conversation in Portuguese, but today he accepted my invitation to talk in English, okay? So based on that, let us know where are you from. It's very nice to know where are you from, because I want to know how far the chemical engineering message reach the world. And Kelson, I would like, my first question is that you did your graduation in US, and many people desires to study in the US, and why you decided to leave US after your graduation and go to India, and why not stay in the US?
Jefferson, that is actually a good question. I ask people usually ask me that question all the time, and usually what I say is this: after I finished my schools in the United States, I did have the opportunity to stay there, and to be quite honest with you, now that we are talking about it, I was given a job offer there to stay in the U.S., but I ran into some problems with my passport, which forces me to come to Angola. Okay, I ended up coming to Angola, and then I stayed here. I ended up staying in Angola as well, but later on came the opportunity to go to India. And I embraced that opportunity. And today I have to say that I'm extremely glad that I did that because that trip to India gave me a whole different perspective about the engineering field. Now, of course, many people desire to stay in the US, and I applaud that because there are many opportunities out there, and especially for foreign students who work hard, study hard, and wish to improve their professional career and grow professionally. I believe that they can have this opportunity there. I believe it is in part dependent on what they do there, the connections that they do create there, which will be extremely important once they finish their studies. And for anyone who is there right now, who is also a foreigner student, I believe that you can stay there, you can go professionally there as well, but you can also be successful in your own home country if the doors are open for you there, of course.
Okay, and so you had some troubles because the visa, you returned to Angola and you decide to go in India, right? And after India, you return to Angola, and I know that you are doing your best to fortify or let your how can I say that strength the Angola engineering. Talk to us a little bit about that. What is this project of yours?
Yes. I was in Angola, as I said. Then I went to India. In India, I was able to go to different states. I was in Telangana, the city of Hyderabad, and later on I went to Maharashtra, the city of Mumbai. In Hyderabad, I did my PG studies in process piping design, and then there was a misunderstanding during this training. So I ended up going to Mumbai, where I finished a PG in process design. But during my time there, I realized that here in Angola, okay, different from India, we do not have many local companies who deal with process engineering.
Mm-hmm.
We don't have it. And usually what happens is when we have projects that require process engineering expertise, we ended up hiring foreigners, okay? Which is good when you want to just get the work done, but it is not good for the local people because you also want to have local professionals who can do the job for you because that helps your country economically. And I was able to figure that out, okay, while I was in India. And my whole idea was, okay, once I get to Angola, once I arrive in Angola, I will try to do something. I will try to do something to make sure that in 4 years, in 5 years, we do have enough qualified professionals who will be able to at least be able to let me put this way, to design, for example, a chemical plant from the conceptual side until the construction, okay? We need that because once you have this type of people, then you can say that you are paving the way, okay, to have a sustainable group of professionals, local professionals will be able to take care of different projects without having to rely that much on foreign workforce. So this has been my fight so far. Okay, I have been fighting so hard to make sure that it becomes a reality, and it is actually become a reality because I was able to, with a group of friends, also from India, we were able to found a local company in Angola, which is called Tech, and I also realized that we still have a long way to go. Okay, we still have a long way to go. as I say, we do have to train the local people. And in order to accomplish that, what I did was to establish work partnership with different companies. So far, we have 2 work partnerships with different companies. We have one with a company in India, and another one with EPC company in South Africa. And during the meetings, I recall I say the CEO of the companies, they say, okay, we are closing this deal because we do recognize that we have many opportunities in Angola. But one of the things that I wish that we, okay, as a partner, we were able to accomplish during this partnership is really to strengthen the professional potential, okay, of the local people in Angola. So I say, okay, I want the group of engineers from Tech to work with your group of engineers from the conceptual side, okay, from the conceptual part of the project until construction. That way I know that we are growing. That way I know that we are getting ourselves prepared to deal with different projects in the near future. It is an ongoing process, and I do recognize that, but everything starts with the first action. I think I've took the initiative, and right now it's just a matter of time, and also having connections like you or many others also helps a lot.
Nice, very, very nice. It's a goal to be achieved. I congratulate you to have this kind of initiative. I hope that in few years people see this video in the internet and saw the Elon Musk of Angola starts here and did an interview to Jeferson Costa in his YouTube channel, okay?
That's true, Jeff. I do recognize that we still have a long way to go, but I am from Angola, and I know that what I do now will also play a major role in the future generation. So if we, as local, do not do anything, we'll do it for you. Nobody will do it for you. So sometimes you have to challenge yourself and challenge those around you as well to try to do better things for your country. As I say, it is an ongoing process, but I'm sure we are on the right path.
Kelson, before I will let you talk about your paper, guys, if you have questions, you can use the chat here and I will address the questions that is related to this topic, okay? But before you sharing your presentation, let me know how LinkedIn is helping you to reach your goal, because although we are friends, I feel that you are a true friend from the internet. We never met each other, but it was because of LinkedIn that we already had some experience together. So what people should know about LinkedIn, or how important is LinkedIn for developing business, for developing the career as a chemical process engineer?
That's a good question, Jefferson. And for those of you who are watching us right now, I would advise, if you don't have a LinkedIn page, I think you should go right now and open, okay? You should definitely be there, because that is the first place that you want to be if you desire to connect with different people in your own field of studies, okay? That is the first thing. You should go and open, because based on the type of information that you are interested in, LinkedIn actually direct you to those people, okay, who share the same goals as you. And I believe the LinkedIn was major, okay, play a major role in what I have accomplished so far. To be quite honest with you, let me say this. If he is watching right now, I think he will be able to recognize what I'm saying. Mr. Vijay, I don't know if I'm pronouncing his name correctly, but if I am, I think you'll be glad. Because I always wanted to share my small articles with other professionals as well, and other aspiring engineers. But for some reason, I couldn't find the time to share. Perhaps I was not that motivated. But while I was browsing on LinkedIn, I came across one of his papers, and I liked the way that he organized the paper. Okay, organized the paper, and I saw this is exactly what I'm planning on doing, but I haven't done so far. Why shouldn't I do the same thing? So I took a look at his paper, and I was able actually to connect with him, and I have been following him since then. And that was, I would say, the first time that I realized how important LinkedIn is. Okay, when you're trying to grow professionally, and when you're trying to connect with people in your field of studies. Okay, not only your field of study, but also people who share the same goals and who are also there to share amazing information that will in some way help you develop, not only professionally, but personally as well. So I would, as I said before, I would advise anyone to go right now, and not right now. Of course, you are here. I believe you should stay here with us right now, just to uh, perhaps
After the
learn
live
something.
session,
Okay,
after the live
but after
session,
live section, yes, yes, I will definitely do that. LinkedIn is amazing. It's amazing. If you are looking for jobs, that is also an amazing place. Recruiters are there, and they also see what you put out there. Okay, your posts are seen by so many people. So if they like it, they will connect with you. Another thing is, as an engineer, you should never be afraid to be judged by your peers. You should embrace it. Okay, you should embrace it at any time, because that is how you grow professionally. So when I put the post, when I put something on LinkedIn, I'm not only put there for people like to say, okay, this guy is doing something, he's always here, he's probably looking for attention. No, no, no. I'm there also to get feedback from my peers, because I know that some of them has already passed through that task. Okay, have already perhaps done the same work, the same type of work. So they will comment, they will say something, and that's how I started saying, I should improve something here. Next time I should do this. And by the time you realize, you say, okay, man, I've come a long way. I've come a long way. I've learned a lot, and I'm still learning. Okay, so LinkedIn is definitely the best platform if you're trying to go professionally, and if you are also trying to connect with different professionals from around the world. Uh, this is how I also get to know you. I also saw many of your posts. It was like, okay, you are very active. You are trying also to bring awareness to the process engineering field, especially when it comes to plant design, which is amazing. And people like you are the ones that I often applaud and do my best to help in any way that I possibly can. Okay?
thank you, Kenzo. Yeah, I totally agree with you. LinkedIn for people that want to build a career, it's very very important. You must know how to use it, but it is very very important. And Vijay Sarat, guys, in my point of view, he has the best chemical engineering content in LinkedIn because he is very organized. He has my admiration. Vijay Sarat is for sure, it's a friend right now. He is a friend of mine, but his content is the top ones. I hope that in some years, I sorry, it's a lie. I don't try to be like him because he has a different mindset than I have. He has a different instruction. He sees things different than I. So I doing more videos. Vijay Sarat is a little bit shy, so he don't get the videos yet. But I am pretty sure if you go to LinkedIn and follow him, you will have something a lot to learn about chemical process engineering plant design. But Kelson, you also did an article in a magazine, and you shared that in the LinkedIn. And the main subject of this live session is to talk about losses in atmospheric tanks. So please share with us in order that people can learn more about the subject.
Yes, Jefferson. And also, before I start talking about the article and the subjects under discussion, I would also like to reinforce the point that you just mentioned about Mr. Vijay just before I start. Uh, I will definitely recommend anyone who is watching right now. If you are a young engineer and you are trying to grow, okay, your career in the process engineering field, you should definitely take a look at his profile, and you should connect with him and try to follow the different type of content that he put out there. You learn a lot. You learn a lot, but let me also say that it also depends on your own effort. You have to do your best, okay? Do your best to read uh, as many books as you can, okay? And also, when you have doubts about something, you should never be shy to ask questions. You always have to ask questions. Don't be afraid to make mistakes. Everyone makes mistakes, so you have to be able to ask questions. Ask as many questions as possible, and you'll see that you always be the one who will win by the end, okay? So that is basically what I have to say about that. Now, I also have to say thank you to Mr. Phil Black, okay, who is the editor for the magazine, because without him, this article would not be published. So I have to say thank you very much, okay? He helped me a lot. Now, when it comes to the article itself, what I have to say is this. I've always noticed that when people talk about atmospheric storage tank, the emphasis is more on the safety side, which I totally agree because it is extremely important, okay, to talk about the safety. But one of the points that people often fail to mention is the economic side, okay? It's the economic side. Because you design a plant, okay, you have to make sure that whatever task that you do, it has to be feasible. It has to be economically feasible, and you also have to show why you should take your advice when it comes, for example, for equipment selection. Why should we select this type of equipment and not the other types of equipment, okay? So it is extremely important. So in this article, I decided to touch more on the economic side, but I also try to show how important we as a process engineer are to the field. Because if it is not for us, maybe we will have we will have not the appropriate equipment in the field, okay? The plant will work, of course, but it will not be feasible. And you also run into different environmental issues and issues of all types, okay? So we as a process engineers are the ones who actually have to deal with equipment selection, make sure that we have the appropriate equipment to meet environmental regulations, but also to make sure that the process itself will be feasible, okay? That was basically what I'm trying to show in the article. And another thing is, sometimes we as engineers, okay, we tend to forget about the fundamentals in our own field of studies, which is something that that I'm afraid of personally, but I think that is also something that I consider to be wrong, okay? Fundamentals are extremely important. Even these codes, okay, that we have, they all depend on fundamentals. What happens is they combine, okay, the experience that they have, okay, what they see in the field, they try to adjust to what they perhaps saw during the school time to make sure that they combine all of these, okay, in something that works in real life, okay? So this has been also one of the things that I have been trying to do is really to put more emphasis on the fundamental concepts in our field of studies and how can we use it to solve real life problems, okay? How we can use it to make sure that the decisions that we are making every single day in the field are the correct ones, okay? With that said, now let's jump into the content that is actually in the article. Now, when it comes to atmospheric storage tank, which you know, okay, are for liquids that are stored at atmospheric conditions. And we have different types of storage units, okay? Atmospheric storage units, we have different types. We have the fixed roof, and we have the flooring roof. For the fixed roof, we can have vertical, horizontal, and for the flooring roof, we have external, and we also have internal flooring roof. Okay, so the question is, you know that they are this type of storage units, but which one should you select? Okay, that is the question, because you have to make sure that the one you select will meet your process requirements. And when you're dealing with volatile liquids, okay, volatile fluids, you don't wish to use for example, a fixed roof atmospheric storage units, because this type of units, they allow vapor to escape. Okay. Now, when the vapor are escaping, it is coming out of what? Out of your intended, right, fluid, out of your desired fluid. So if you are selling that fluid, or if you are buying that fluid from somewhere, you are clearly losing some money. Okay, you are clearly losing some money. So you have to see, okay, how much you are losing, and why should you select different type of equipment. The importance is there, okay? To just make sure that you are protect the environment. You are also making sure that you have a process that is well designed. Now, hello?
I'm listening to you, and
Yes.
you plan to share the magazine?
Yes, I will share the magazine right now. But also, before I show the magazine, I'll say this. There are many different regulatory entities, okay, who can help you with this type of exercise that I'll be showing right now. And one of them is, of course, is the AP42, okay, is the AP42. AP stands for air pollution, and 42 is just the number of publication. In chapter 7, where they talk about air emission, they explain details. They explain details about all the calculations that you need to take care of in order to figure out how much of your fluids you are losing when using fixed roof, storage units, or using flooring roof, okay? And I would advise anyone, okay, to take a look, just to make sure that you are familiar with the information that they have there. The document is often updated. I believe the last version was updated in 2020 is the last version. You can find different types of equations there with all the explanations to help you with the subject that I'll be talking right now. So I will show right now the article, okay? And the reason why I don't have a PowerPoint here is because in the article, I actually explain step by step how should you address the problem. So instead of having here a PowerPoint slides, I will share with you the article, and I will start explaining from there.
Jahid, I have seen your question, and I will address your question to Kelson in the end, okay? It's interesting that people understand what is needed to start a career in chemical process engineering. So don't worry, I will address this question, okay? Just let Kelson finish his presentation.
Yes, Jefferson, can you see the...
Yes, perfect.
Awesome. So it is also important to mention that there are different types of losses, okay? There are different types of losses that take place in atmospheric storage units. And one of them is the flushing, okay? You have the flush loss. Of course, when you're pumping the liquids using the pump, right? Using pump, Once the liquid reaches the atmospheric unit, since it is perhaps at the lower pressure, okay, so you have flushing taking place. Because of the difference in pressure, you have the fluid will start to evaporate. That is one type. Then we also have what is often referred to as working losses. Is basically when you're filling the tank, what happens is you push all the vapor that was initially inside the tank out as you start filling the storage unit. Mm-hmm. Another one is also the breathing. We have breathing losses. You know that you have the fluid inside the storage units. Okay. During the day, there is a change in temperatures. Temperature might be increasing, so you also have losses because of that. And you might also find the loading losses. Okay, the loading losses. Once you take all the fluid out of tank, there is always the vapor that you stay there, right? So there is always some loss associated with the storage units. The one that I have here is linked or associated with the working losses. Okay, you have a tanker who is bringing in fluids, and as you start filling the tank, that amount of vapor that was initially there will leave the tank. Mm-hmm. The question that you have to ask yourself, okay, if you don't have, for example, a proper unit in system, like a floating roof, that we actually trap the vapor from escaping, how much of that vapor, okay, is in terms of mass, and what is the loss that you have, okay, the financial loss that you have because of that in your, let's say, in your annual sales revenue, if it is a fluid that you actually need to sell to someone else, okay? So to do these calculations, okay, you can, as I mentioned, you can refer to the AP42, okay? AP42 chapter 7.1 talks about the working losses, and you can find it online, and you can take a look. But here in this article, what I did is something different. I used some of the fundamental concepts that we know from thermodynamics to do the same type of calculations, okay? But my challenge for you right now, who is watching this one, is you take the same example and you try to solve the same problem by using the AP42, okay? Working losses, that is chapter 7.1, okay? Do the same calculation, and then you will see what is the difference, okay? What is the discrepancy between the two results that you might find. Mm-hmm. Yeah, this was one of the short P&AD that I was trying to develop, just to make sure that everyone is clear about what's going on. So basically you have a tank here, right? This brings the fluid, and for some reason you decide to use a fixed roof atmospheric tank, but the fluid that you are handling is hexene. We know that hexene is a volatile liquid, so by this point, you should know that since it is a volatile liquid, you should not be using a fixed roof atmospheric storage units, okay? You should use a different type of atmospheric storage units, which is the floating roof atmospheric storage units, okay? You should know that by now, but for some reason, use the fixed roof. Maybe there is a problem with your floating roof, and you decide to use this one. The question is, how can you calculate the losses? And to accomplish that, I have here a few steps. I have here a few steps that you might follow to solve the problem. And as I say, it is based on the fundamentals. You have to be familiar with vapor pressure concept, the Antoine equation that we allow to allows you to calculate the vapor pressure. For instance, okay, here you have the problem, okay? Here you have the problem statement, which I advise you. The reason also why I'm sharing the magazine with you is for you to go there and take a look at the magazine, not only my article, but other articles as well, because you might find amazing articles that might be helpful for you, okay? Instead of reading the problem itself, I will basically talk about how should you address the problem and the significance, okay, that you might find from this problem. You have the information. The first step, of course, you have to find, okay, what is the vapor pressure? You calculate the vapor pressure of the liquids, okay, at the tank at the operating temperature, which in our case is 30 degrees. Once you have the vapor pressure, you have to calculate the molar fraction of your components at the same temperature. Okay, you have to calculate the molar fraction. Once you have the molar fraction, which in our case is 0.25, you can calculate the molar fraction of air as well. Once you have this value, you might calculate the mass of your fluids that you lose. But to do that, you also have to estimate how much of the fluid, the vapor, are you actually losing, is leaving the tank. And you have to make a few assumptions at this stage. But as I said, if you use the AP42, okay, if you go there, you use different equational states, which incorporates, which is more, how can I say, you might be able to find more realistic values, okay, than the ones that I'm showing right now, but they do not deviate that much. That's the reason why I say you should go there, use that equation, try to solve similar problem and see how much it differs from the values that I have here. But let's say, for instance, that you are pumping, okay, you pump the liquid, the tanker is there, and this is loading the fluid to your desired storage unit. If the pump capacity, let's say, is 30 cubic meters, and you need to unload the tanker in half an hour or in 1/3 of an hour, as I have here, okay, so the pump capacity should be, let's say, 90 cubic meters per hour. So how much of the vapor are leaving the storage unit once you are loading the tanker? You can assume to be exactly the same volume, okay, as your inlet fluids, as the pump capacity, as you have here, also 90 cubic meters per hour. And once you have this value, now you can calculate the volume of hexane that is also leaving as a vapor. Ideal assumption is used, okay? If you use the ideal assumption, this problem becomes straightforward without any problem. You know that the molar fraction of hexane will be equal to the ratio of its volume divided by the total volume. And from here, you can calculate the volume of hexane that is leaving the unit, okay? The molar fraction is 0.25 times 9, you get 22.5 cubic meters per hour. We know that your fluid is being unloaded in 1/3 of an hour, so you can figure out, and the process takes place once per day, so you can estimate how much of your fluid is losing per day. So here we have 7.5 cubic meters, okay, that correspond to 7.5 cubic meters in 1 day. Please, if you have any questions, feel free to ask, okay, and I'll be more than glad to answer any of your questions by the end of this presentation. Once you have the volume, the other thing that you have to calculate is the density, okay? The density needs to be calculated, and you have to make sure that you calculate the right density. The inside temperature is at 30 degrees Celsius, so you have to find the density at 30 degrees Celsius, which you also can calculate from the ideal gas equations, the PVT, okay, PV equal to nRT. From there you can you can find these equations. Just need basic math, and you'll be able to figure out these equations. From there you can calculate the density at 30 degrees Celsius. The normal density at 0 degrees Celsius, you also can figure out, which is simply the molar weight divided by 22.4 liters, okay? Or you can convert that into your desired units. Once you have this value, calculate the density at 0 degrees Celsius. Once you have the density in the volume, you can calculate the mass of the vapor that you are actually losing. Once you have the mass of the vapor, that in our case is 25.9 kg per day, now you can subtract this value from your theoretical value. Because initially you have the total amount, right? You bought, let's say, 10 cubic meters of your liquid, right? You know also the density of your liquid, so you can calculate the mass of your fluid. That is your theoretical values. As I say, there are many different types of losses. And here, just for you to have an idea, it's just one type of loss, that is the working loss, that I'm basically trying to calculate, okay? So you have different type of losses. Once you calculate the mass that you are losing, and you also know the theoretical amount that you have, now you can find the remaining amount that will stay inside the tank, in the liquid phase, that you will eventually sell to your client. So the remaining will be the initial mass that you have minus the exiting mass, okay? Right now we have, initially we have 30 cubic meters. The density of Xine is 655 kg per cubic meters. If you multiply these values, you get this result right here, okay? 90,650 kg per day. That is the initial amount that you have inside your tank initially, okay? That is the theoretical value that you have. And later on, how do you calculate the remaining amount? The remaining amount is simply this initial amount minus the amount that you are actually losing, okay? Which is the 25. Once you have this remaining amount, you can calculate the volume, which I refer to as the remaining volume. The remaining volume is simply the mass divided by the density of your fluid. And you end up having the final amount that you will have in liquid phase that you sell. From this value, of course, you have to know how much of your sales revenue, okay, since it is a product that you are selling, how much of your sales revenue will be maintained, okay, and how much of it you are also losing. So the remaining sales revenue will be calculated based on the remaining amounts that you have, and in our case we have 29,000, okay, 960 liters per day. If we are selling our products at $1.60 per liter, okay, then you have to multiply, okay, then you have 365 days per year, but your reduction factor, okay, it is just 0.9, which basically you are telling me that you are operating 330 days per year, okay? So what you end up having is this final result, okay? Roughly $60 million per year. This is your remaining, okay? This is your remaining, and then you can find the theoretical. If you are not losing anything, how much will you actually be making? Which is the next step. You find the theoretical sales revenue, and once you have the theoretical value, then you can calculate the loss. The loss is simply the difference between the theoretical value minus the remaining, and then you see that the loss is about $25,000 per year, okay? For some, they might say, okay, it is not that much, but as I say, you have different types of losses, okay? You have different types of losses, and if you combine all these types of losses, the total loss in sales revenue will be actually much greater than the value that I have here. And another point that you have to take into account is that all these results here are a function of the temperature. You know that as you increase the temperature, right, the evaporation rate will also increase. So you are losing more vapor. And plus, if you are using the wrong type of equipment that we are using right now to do this calculation, which is the fixed roof, you are not trapping the vapor. You are having increase in temperature. With that, you are also losing a large amount of your desired products, okay? So what I did was I based on the problem statement which I created, I say that, okay, let's have the temperature change from 30 degrees Celsius to 40 degrees Celsius. And then you can use the software. Here I decided to use MATLAB. I like to use MATLAB. So I did the simulation with MATLAB. And you can actually see how the temperature having strong, okay, effects on the losses that you have here. Okay, as you increase the temperature, as I say, the evaporation rate increases. With that, you are losing large amount of vapors because you are not using the proper equipment, and with that, you're making less money, which is bad, which is extremely bad. Okay? So this is the reason why you don't see fixed roof storage tank being used for volatile components. Okay, the losses are there, and when you combine all the losses, the loss in sales revenue is tremendous. Okay, so this is what I mentioned before. We as a process engineer, we play a major role, and we can avoid all these losses. We can avoid all these losses by selecting the proper equipment. And when it comes to atmospheric storage units and you are dealing with volatile liquids, you have to make sure that you are using a floating roof storage unit. Now you have the external and you have also the internal. For the external, you might end up having also different types of problems. For example, you have the rim seals. Okay, they might wear out with time, so you might also having different losses from there, even though you are using the external. Okay, you are using the external one. You might also have losses from there. So you can combine. You can have the internal, because the internal, they have the protection there, but you also have a fixed roof on top, just to make sure that you prevent further losses as well. Okay. This is basically what the article shows, okay? It shows that when you select the wrong type of equipment, you end up losing, okay? You end up losing, of course, you don't want to upset your boss, and also you want to make sure that the client is making the best, okay? He is improving his sales revenue, he's making more money, and you as a process engineer, you are making sure that you are also protecting the environment. This is a big subject, and I know that, but this is basically was me trying to show how important we as a process engineer are, and how important it is to know the types of equipment that must be used to meet the process requirement, but you are also making sure that you are optimizing the profits. Okay. Again, I would advise anyone, okay, to take a look at the article. And Jeferson is here. If you have any question, you can find me on LinkedIn, or you can get in touch with Jeferson. You can connect with me, and I'll be more than glad to share other information that I have with you regarding atmospheric storage units. And if you also would like me in other opportunities to talk about the AP42, okay, chapter 7 in more detail, and use some of those equations that you might find there, and also explain in more detail, I'll be more than glad to do that. And it is also up to Jeferson. We can use his platform, since we are talking about this article right here, to perhaps talk about the same subjects. Kelson. Jeferson, this is basically all that I have to say about this article. And once again, I advise anyone to take a look. And I'm open for questions, or if you have anything to say, please go ahead.
Okay, I have some comments here in the chat I will share with you. And about the article that the Kelson is talking about, he shared with me the link. So for those ones that are members of my INPROCESS Telegram channel, I will let it available there. So you can get the link in my Telegram channel INPROCESS. And the link to join the Telegram channel is available in the description of this video. In any case, you can connect with Kelson in LinkedIn also. So it will be a pleasure to him to share the link with you, and you can see the post that he shared in LinkedIn to find the links. Okay. And I have a question.
Jefferson.
Yes.
Yeah, just one point. I know that I'm kind of running, talking a little bit faster. Please, if you at any point, if you didn't understand something, okay, feel free to ask. Okay, I'm more than glad to go back to the article, discuss with you a few points, because I believe that some of the points that are mentioned in the article, they are fundamentals, and everyone as a chemical engineer should have a good understanding of all the stuff that I have shown. This is the basic stuff. So we as an engineer, we have to make sure that we master all this stuff. Okay, if I run a little bit too fast, and if you find yourself not understanding some of the stuff that I mentioned, feel free to ask. Okay, this is the platform for you to do that, and I'm here to answer any question.
No problem. Don't worry, Cass. Don't worry. I have my questions, and I have some questions in the chat. Okay. My first question to you is: you did your article based in an existing system, or you just used an ideal one? How was your idea to start this article?
Yes, actually, it is a I run into problem while dealing with the projects. Okay. But instead of using to create the article, instead of using the AP42, I say, no, let me try to show other engineers, okay, the same problem that I was facing while dealing with that task, but by using the fundamental concepts in chemical engineering to address this problem. So this is a real problem, okay, this is a real problem that I was facing, but I used some of the concepts, okay, to show the same exact problem, but just in a different way. Okay, the problem was actually a real one, and yes, it was a real problem. But the idea is how I addressed the problem. Once again, was based on the fundamentals, because it was intentional. I was really trying to show other faults, especially in the field. How can you actually use the basics to make sure that you draw the right conclusions, okay, that will help you in your decision-making process.
Why I ask you this? Because I have a question here, some comments about Sumit Katrika. Hi Sumit, nice to have you here. Sumit is an INPROCESS Booster member. And his comment is, how are you selecting Brefer's valve for this process? And also, as we know, hexane is harmful, so if it's vapor released from tank, then it outlet connected to flare. So what I understood is that usually or eventually the vent will be connected to the flare system, or flare header, but it doesn't prevent from losing gases, right? It's just besides going to the atmosphere, it goes to flare, but the pressure, operation pressure at the flare, it's very, very low, so you can consider that its tank is connected to atmosphere, no problem. And he asked about if in the project any vapor condensing system to recover the vapor was considered. It would be a way to prevent these losses?
Yes, that's a good point. I didn't catch his name, but that is actually a good point. That is a good point, because this is the beauty about process engineering. Yes, you can have a compressor there to recover the vapors, and then you might be able to condense, okay, this vapor and send it back to the units. which is good, but some of this strategy, they are very expensive. Okay, they are very expensive, and as an engineer, sometimes we are also trying to reduce the costs. Now, a good point that he mentioned, yes, hexane is harmful. Okay, so of course you not be using an open atmospheric tank to store hexane. No, no. The whole idea was just to show, okay, when you select the wrong type of equipment, you'll be losing volatile components if you're trying to store volatile components. You don't want to do that, okay? You don't want to do that to prevent. Now, when you have harmful species, like he mentioned correctly, yes, you can send it directly to flare, as Jefferson also mentioned it, to be burned. And you also have to make sure that you have to calculate the threshold value, the allowed value that can be sent to the atmosphere, because if you do the safety calculations and you make sure that the concentration is actually below the threshold value, then sometimes it is okay, it is okay, but you have to know the type of species that you're dealing with. Okay? That is actually a good question. To say once again, yes, you can have a compressor, okay, to recover the vapor, then you can condense it again, then you can send back the unit. But sometimes this strategy is very expensive, and I did thought about that as well, okay? I did think about that as well.
Yes, there are some kind of issue that depends on the specifics, because if you need to recover, you need to think about the equipment, so there is capex associated to that, and there is the OPEX associated to that. If you need to compress, eventually you need to use electrical power, so it's expensive. And if the economics doesn't match, sometimes it's better to have a small losses than try to recover that, right, Kelson?
Exactly, yeah.
Okay, and I have a question from Vijay, and as you mentioned in briefing and out briefing, would you recommend tank to have PR? I think that's PSV or PRV for atmospheric design tanks. What do you think about having PSVs in storage tanks open to atmosphere, Kelson?
Yeah, just so if I understood correctly, that's a question from Vijay. So he's watching. So
no, it's not Vijay Sarat, okay? It's not Vijay Sarat. It's another Vijay.
Oh, okay. So, hello?
Yes, we are hearing you.
Yes. You can have, I wouldn't advise that to have a PSV, since we are dealing with atmospheric storage units, okay? The danger is very low, so you don't have to do that, because as I mentioned before, sometimes you're trying to avoid costs. You use when needed, but in this case for atmospheric storage units, you don't need that, okay? You definitely don't need a PSV to...
Sorry, it is about pressure vacuum relief valve. Sorry, I didn't understood the letters.
Yes, that is a breather valve.
Yes.
That's basically a breather valve. Yes, you do have, because you have a storage unit, right? And the fluid will of course, by some time, you'll be taken out of the tank. And once you take the fluid out of the unit, you're creating a vacuum space out there, okay? So to avoid that, you can have a breather valve, okay, which is the one that he's referring right now. You can definitely have that. That is mandatory. You have to have that to prevent damage to the storage unit, okay?
Yeah, I have dealing with some storage tanks in air separation units, and what happens when we have colder fluids going through the top of the storage tank, the gas phase will condensate, so that we can form a vacuum, as you said. And if the vacuum is hard enough or strength enough, you can have employment of the vessel. So if you fill your storage tank from the bottom, you will increase the level from the top, from the bottom to the top. So you compress the gas and you will increase the pressure inside the storage tank. But if you do the opposite, if you load from the top, eventually you will condense the gas phase. So that's why you need the breathing valve or the pressure vacuum relief valve to compensate
Yes.
these losses in volume, right? So this is it.
Absolutely. And yes, you often put the liquid from the top, okay? And when dealing, now that you're talking about it, also when dealing volatile liquid, you might have a J type of pipe, okay, or a D pipe, just to prevent any type of just for safety reasons, okay. But yes, you do need to have a breather valve, just to make sure that when you take the fluid out of the units, you are also protect the unit itself. And once you putting the fluid, also filling the tank, okay, you also protect the units.
Guys, thanks a lot for your questions. If you have questions, you still have time. And Kelson, thanks a lot for sharing your article here with me in this live session. And before we finish, I would like to address to you some questions. And now it's more related to development of young engineers as you are doing this nice work in Angola. What you identify as the key subjects or the key skills that the freshers engineers must have to start working as chemical process engineers in plant design?
Yes, Jefferson, sorry, I was having difficult problem here with my sound system, but if I understood the question correctly, you mentioned the skills that someone needs to have in order to start his career as a chemical engineer.
Yes.
For plant design in particular, right?
Yes.
Yes. Again, the basics are extremely fundamentals, okay? You need to have a solid understanding of mass and energy balance. That is the basics. You do have to understand that. But also, you have to have a good understanding about fluid hydraulics. You have to be able to design, how to develop the basic stuff. You start with the block flow diagram, if it's the basic. Then you start to growing, okay? Know how to develop a PFD. Then you start to develop the PNAD. You have to also to start doing your best to understand all these different deliverables, such as isometric drawings, and this is the basics, okay, that you have to start understanding. And for someone who is starting, like, let's say, start with the basics. Line sizing, you have to understand, okay, do calculation about line sizing, pump hydraulic, how to size a pump. And I think this is the basics, because this is very complex, okay? The field itself is very complex. So in order for you to get the top, you have to start from the bottom. And the bottom is, as I mentioned before, is the fundamentals. Energy mass balance. Start to understand and construct by yourself some of the process engineer deliverables, okay? PFDs, PNADs, understand all the things. And then you start taking a step further. How do you start, okay, now that you, for example, understand what is required to make a PNAD, and you have different equipments there, such as pump, you have pipelines or piping. How do you size all these equipments? You have to know. Okay, it takes time to get deep knowledge about all these equipments and machineries that are there, but you have to start with the smaller one. And I think for someone who is starting, line sizing, pump hydraulic, I think this is the basic stuff, okay? This is the basic stuff, and then they can start building from there. Because the work, as you say, as you know, Jefferson, it is very complex. It takes time. So if you don't understand the basics, then you just make your life very difficult. And another thing also is the softwares. You have to understand simulation, how to simulate different processes. Okay, Highs is there. Okay, I use a lot Aspen Plus, because this is software that we use during school in the United States. We use more Aspen Plus, so I have a deep knowledge about that, and most of my simulations I perform with Aspen Plus, and Highs is also there, especially for the oil and gas industry. Highs is there, so you also have to know how to use all these simulators. It's extremely important, especially nowadays that we are moving fast pace, so you have to master all these softwares.
Okay. I have some questions related to the presentation, and I will take only these two questions to finish the subject's presentation, okay? One of them is from Vijay Sarat, how to minimize losses while the atmospheric tank is in operation.
Yes. Sorry, just it's taking a while for me to hear the sound to arrive here for some reason, I don't know. But yes, my first point is what type of storage units, atmospheric storage unit are used? Because even during operation, one of the quickest way to minimize losses is by using the right type of equipment. Okay, what type of fluid are you handling? Okay. If you are handling a volatile fluid, then the first thing is to use a floating roof atmospheric storage units. That is the first step, because this will help you to minimize losses even during operation. Okay? It will help you a lot. Okay? Now, there will always be some losses there, okay? But if you use the right equipment, the losses will be minimized. There are different techniques that you can use. One, of course, was the one that we mentioned before. You can have a recovery system that can be implemented in the system to recover the vapor. And then, especially if you are dealing with a very expensive fluid, then you have to do the economic analysis to see if it is feasible to have a recovery system attached to the storage unit. Okay?
Okay. And I have another comment from Sumit, and I will answer this one, okay, Kelson? If a particular fluid decomposes, if it comes contact to air, so to prevent this, what kind of blanketing use, like nitrogen blank or FOA? And I have another question of Ifinwa. There are some names that is difficult to me to talk, okay, because my Portuguese language. But when do we design a tank to have different inlets and outlet nozzle, and when do we design the tank to have the same inlet and outlet nozzles? So I will answer them, okay, Kelson? First, talking about Sumit's comment, everything depends on the project specifics. If we have a fluid that cannot get in touch with air, we need to have another source of inert fluid to do the blanketing. We call that blanketing, and eventually, depending on your process, you need to have a pressure control in order to make sure that you will not have vacuum, or if you will not have overpressurization. So how is possible to evaluate what are the compatibility of the materials? First approach is to get the material safety data sheet. There usually you have the safety information from your component, and it talks about flammability, reactivity. So it is a good source to know what kind of materials is compatible one with another. And talking about project specifics, how much nozzles, and if nozzles is the same or different from the outlet. The nozzles is part of, or it's related to the pipe sizing. So if you are The inlet nozzle is related to the amount of fluid that you are transferring to the tank. And the outlet nozzle is related to the amount of fluid that you are withdrawing from the tank. So all of these will depend of your project specifics. It will depends on the customer requirements. So it's not possible to answer this kind of question here because you need to evaluate a specific design to verify how much nozzles I need to have a level transmitter. It will be differential pressure, it will be ultrasound, it will be radar. So there are a lot of issues related to that as Kelson said, it takes time to learn, but you can save that if you have someone to teach you, or if you go to books. And you talk about books, Kelson. As you know, I have a mentoring program and I have a Aspen High Seas training program, and most of the time I get books to revise some concepts and some fundamentals, and sometimes I get frustrated with them because I saw that much of them repeat them, and sometimes I don't get the answer that I need to, but it's just a comment. So these days I find very, very interesting looking for papers for a specific process. If, for instance, I want to know more about liquid hydrogen, so instead of looking for books, I usually look for papers in order to have an overview about that. And having the overview and knowing the fundamentals, it's easier to understand the process. So that's my point of view. What do you think, and what kind of sources do you use to improve your knowledge?
Yes, Jefferson, that is actually a good point because you cannot just open book without having any basic idea about what's going on. You need to have it, some sort of a foundation, okay? So this paper, they actually give you some sort of the basics that you need to understand more detailed information that you might find in the book. This is, once again, why I have to congratulate you on this type of interview that we are having right now, okay? Because it opens doors, because we are engineers from all over the world, but we can see that we converge at some points because the information that we are talking about is the same thing, but we condense it in a way that anyone can understand it. For example, this article that I'm sharing right here, you can see that it has some of the fundamental stuff in chemical engineering and some of the use. How can you use it? Once you know this basic stuff, now you can open, for instance, a book and learn more about it, okay? For instance, we're talking about the EP42, okay? Which is basically a standard that you can use when dealing with air emissions, okay? As I mentioned, they have more information there, but if you just go there without having any idea, that can get frustrated, okay? You can get lost, so you're trying to avoid that, okay? For example, if you take a look at this article or any other article to talk about it in a more simplified way, it can give you an idea about the subject itself. Okay, my idea to you is, or my answer to you, as Jeff mentioned, is start with the basics. Read papers, follow people who creatively create this type of short articles, okay? But short article will talk about major topics in your area of interest, okay? Once again, Jeferson, the problem that you have, okay, in-process booster is an amazing problem, because it is not all about how to learn how to use the HYSIS. It's not about it, because once you learn how to use the HYSIS, you get across different terminologies that we as a chemical engineer use. And perhaps some of this terminology are some that you perhaps didn't understand very well during your school, okay? But there you'll be able to master it, to understand more about it, and see how a small change in a process, for example, variable will affect the rest of variables in your simulation. Okay, all these correlations are very complex, but once you understand the basic, these complex stuff becomes easy to understand. Once again, start with the basics, follow the right people, and I think we are doing a great job today here, mention about some of them, like Mr. Vijay is one of them. You as well, you have to be humble enough to say this, you as well have been doing an amazing job, and I think people should follow you, not on LinkedIn, but also should uh, uh, try to get access to the information that you have in your process booster. They can, of course, get in touch with you and see what the requirements are, because this is an amazing, especially for aspiring engineers, people who are starting right now. I think that is a boost. And for experienced professionals as well, who are trying to improve their software skills with ISIS, that is also a plus. But once again, start with the basics, understand the basics, then jump to the big stuff.
Thanks
And
a lot.
again, and
Yeah.
one more thing, don't be afraid to ask questions. Okay, don't be afraid. And this is one thing that I've been learning. Okay, learning is a continued process. So I've been learning. You have to ask questions. If you don't ask questions, you might think that you know the answer, but you actually might be missing something. But when you ask questions, you are open the door for more discussions. And when you're having this type of discussions, you'll see that you always learn something new. Okay? Don't be afraid. Ask questions. Start with the basics. If you are having any problem, understand the basic. Ask questions again. Get in touch with the right people. Okay, talk to them, and you'll see that you will learn a lot.
I totally agree with you, Kelson. And what people sometimes send me message, can I ask you something? What I say to them is, ask is for free. So don't worry about that. You can ask me as many questions as you have. The only alert that I can give you is that first, I will answer as soon as possible. And eventually it can get some time, okay? Because Kelson has his job, has his activities, family, and etc. I am also the same. I do free content. I have training to record and etc. So I do my best to answer all questions, and feel free to share them. And I like to use this kind of environment to answer them, because more people are benefits from questions from one person. And Kelson, we are more than 1 hour talking to each other. Thanks a lot, my friend, for sharing your time with us, not only with me but with us. And I would like to know your final considerations. And if you have any specific question to me, feel free to ask them, and I will do my best to answer. Okay?
Yes, Jefferson, once again, thank you very much for having me. It has been a pleasure. And for all of those who are watching us right now, I have to say thank you for tuning in. Okay, hopefully we will be able to get something from this meeting. Of course, the article is there. You can have access. I think Jefferson will share with you. We found a way to share with you the magazine. You should definitely take a look at the magazine. And as I said, there you also find more information about me. Okay, and once again, the fundamentals are extremely important, and this is one of the reasons why I work on these small articles, is really to show how you can use the fundamentals to address different problems that you might face in your professional career. Sometimes when you deal with complex problems, sometimes the solution might be very simple, actually. Okay, when you understand the basic concepts, okay, you understand the basic concept, and you actually can show your boss that okay, we don't have to spend a lot of time with this problem. If you use this basic concept, we can actually see, okay, the problem. We can see the problem. We can address the problem right away. So the fundamentals are extremely important. and start the fundamental, and you start to grow from there. And whenever you get stuck, don't be afraid to ask. Okay, I'm here. I'm not that expert at all. I'm still learning. And this is the reason why I'm connected with Jeferson Costa, because I know that I can learn. I can learn from him. Okay, this is why I follow different people on LinkedIn and connect different people. This is the goal. This is the goal because I also want to grow professionally. And this is the only way that I know is by asking questions, getting connected to people, and and just be myself as well. Okay, you have to be curious. You have to be curious. This is engineer. You don't have to be afraid. It is an amazing field when you know what you are doing. Because when you don't know what you're doing, things become just very frustrating, and you don't know that happen to you. So one way is to get connected to the right people, ask questions, get yourself acclimated with the basics, master the basics, and I believe you have a successful career.
Okay, so guys, this is it. I hope you like it, and I'll see you soon in the next meeting. Bye bye.